Morning. My name is Carter Smith, and we're going to talk about fiber optics. So today, pretty much, I'm going to cover what is fiber optic cables, what kind of service do we have for it, and also pretty much how it's made. But we're going to start off. Pretty much, it's used for medical uses, for surgery, they like surgeries, and for defense and government, where we can for military uses and all, and for some little small networking, and we can also do for data storage for like larger networks, transfer speed and all, and we can also use it for communications, where the fiber is layered and used for transmitting and receiving purposes. Networking, like I said, you can use for like a giant community or small little network-based industrial and commercial uses. Because I'm pretty sure we can use it for radio purposes, broadcasting different signals and all, and with also broadcasting and NCTV, we can it's pretty much use fiber optic cables and for wiring CTV, HD TVs, internet video, on-demand, and other applications. And this is going to be a little quick video of the speed test of, since we have Google Fiber, I'm pretty sure Google Fiber uses fiber optic cables, and this is the upload speed and download speed of fiber. So here's my question: overall, how much megabits do you all have at home right now?
100. 100.
And pretty much this is how it's made. The outer jacket to protect it. The reinforced material, just so you want to strip it back more. The plastic shield to protect the glass fiber. Cabling, like I said, you can use it for networking. Speed that transfer is 100 plus megabits per second. The average price per node is more experienced to me, and connector size is small. Like I can see, in the picture right here, because there's different connectors you can use for it, but it's one of the little standard ones. So the maximum cable length is up to 2 kilometers. And this is the different speeds that you can, between broadband and fiber, which within a 2-hour HD movie, 3 gigs or 4.5 gigs, standard 2 megabits per second, you'll download it in 32 minutes. But if you have 100 megabits, you'll download it in 4.5 minutes, and if you have 1,000 gigabits, it'll download in 25 seconds. And how it's made is, they don't use normal glass. They have to use, they have to treat it first, get it down to a certain state that it has to be used for. So this is how they make it in the factories, which they don't, and they don't wire that. They just make it the way it is right now.
Every time you talk on the phone or go on the internet, what you say or type travels to its destination through fiber optics. Voice and data gets transmitted via pulses of light through hair-thin glass fibers. Those fibers start out as large glass tubes. First, workers unwrap the tubes. submerge them in a corrosive bath of hydrofluoric acid that removes any oil residues. Then they set a tube into each end of the lathe. As the tubes spin, they're heated with the hydrogen-oxygen flame. When the glass turns white, it's getting close to hitting peak temperature. At about 3,500 degrees, the two tubes fuse together. They put this new longer tube onto another lathe. As the tube spins, they inject a mixture of chemical gases inside, while the traversing burner heats everything up. The gas mixture contains liquid forms of silicon, an abundant chemical element found in nature, and germanium, a chemical element similar to tin that's used as a semiconductor in transistors and other electronic devices. As the gases heat, they undergo a chemical reaction that leaves a white soot on the inside of the glass tube. The heat fuses the soot, forming what will eventually become the core of the optical fiber. The glass tube itself will form the fiber's covering. When there's enough fused soot, they turn up the heat until the soot itself turns into glass. Then they heat the glass tube enough to soften it, and to soften the new glass inside. The intense heat eventually makes the tube collapse on itself to form a solid rod. The internal structure of the optical fiber has been achieved, but it's in the form of a big bulky rod called a preform. So the next step is to fit it out. First, they excise the preform from the uncollapsed section of the glass tube. Then they install it vertically into the drawing tower, which will draw out the final shape. The drawing tower's oven heats one end of the preform to 3,600 degrees. The glass softens. Gravity helps pull it down, like honey dripping from a spoon. Then, using a block of glass as a weight, they stretch the soft glass and keep stretching it until they form a thin glass fiber. A series of pulleys measure the tension on the fiber as it's being drawn. A special monitor makes sure the fiber is precisely the right diameter, just 5/1000ths of an inch. Then the fiber passes through UV lamps that bake on an acrylic coating to protect against dust and other contaminants. Finally, the fiber is rolled onto a drum. From here, it's either shipped out as is or put into a cable. Fiber optic cables are expensive to produce, but they're smaller and lighter than traditional copper cables. They carry more information and need fewer repeaters to keep the signal from deteriorating. And unlike copper cables, they're immune to electromagnetic interference. They're also hard to tap without being detected. And all this is made possible by a complicated process based on a very simple principle: light traveling through glass.
And that will pretty much end my PowerPoint.
All right, guys, we'll take a moment, fill out your audit surveys front and back. You're evaluating Connor today on such content of this presentation. We'll be rating on explaining his organizational skills, methods for instruction delivery, his credibility and communication skills, and his group presentation. Take a quick It's got his name and topic of his presentation up on the slide for you.